I got directed to another video claiming evolution is a hoax. Let's see what arguments will be used this time.
Hey, is evolution a hoax?
No. No, it's not. Okay, are we done? Easy one this week. Oh, I guess there's more. Let's keep going.
You know, when I became an atheist, I began to watch the debates between atheists and Christians, and evolution kept coming up as a reason to why God didn't exist.
Like the argument from evil, saying that evolution disproves a God isn't a good argument. It is often used as a way to explain things, like the diversity of life on this planet, without needing to invoke a deity, but you can't say that since evolution occurs, there is definitely no God.
I didn't really get why atheists were using evolution as one of the main points to say that God didn't exist. So when these statements kept getting raised in these debates, that really put it upon me to go and check out evolution.
I've said it in the past several times, evolution and atheism are not intrinsically linked. There are believers in a deity who also accept evolution, and there are people who don't think there's an intelligent creator behind everything who also don't accept evolution as the explanation for biodiversity.
And I'm going to link up an article that's going to be linked in the bottom of this video that comes from PBS, and it talks about the evolution of the whale. And in that article, there's a lot of language that is used that is very telling.
I checked the article he's talking about, and it's dealing with how we can be reasonably sure that sea-dwelling mammals came from land-based ones. I'm not sure what you mean by language is very telling. It's using what we know about evolutionary theory to explain why it's thought that one set of mammals moved from one biome, the land, to another, the water. Since it's using accepted scientific principles, the article doesn't need to add evidence or explanation for those principles as well.
To start off, the story of the evolution of the whale goes something like this. It started off as a smaller, land-dwelling creature, and then evolved into the sea-going whale that we now see today. So that's something in itself. The whale, if you didn't know this before, started as a land-dwelling animal. The beginnings of a whale supposedly started with a creature called Pakicetus. And let's take a look at a picture of Pakicetus. Now let's take a look at the modern day whale. Let's take a look at that one more time. Does anyone recognize a problem there? Do you see the differences just in appearance of those two creatures?
Yes, there are noticeable differences between the two organisms. It's almost as if moving from a new environment will cause an organism to change to better thrive in that biome and move through various stages, or transitions, over time. But apart from the size, they're surprisingly not that different. While the bone sizes have changed, the layout of the skeletal structure is remarkably similar.
Well, the problems get a little more difficult as we go on. You know, in talking about the whale in the article that I'm going to reference, I'm going to start off with a little quote from that article. And it says, "Some details remain fuzzy and under investigation, but we know for certain that this back-to-the-water evolution did occur, thanks to a profusion of intermediate fossils that have been uncovered over the past 2 decades. Profusion. Well, when it comes to this profusion of intermediate fossils, this large amount of fossils that we have, you know, this very big transition sequence, here is the transition sequence of the whale. There's a problem with that.
Yes, those are the currently known transitional fossils for Pakicetus to whales. We don't have the entire history, and they admit it. I hate to break it to you, but not everything gets fossilized. You seem to be arguing that if we don't have a record of every single transition from one organism to another, then we have to claim... What was the title of your video again? Oh yeah, we have to claim that evolution is a hoax. But you have it backwards. We are not using the fossils of Pachycetus and whales and the other fossils we found in between to prove evolution. We're using our knowledge of evolution to help trace the path from one organism to another. That's one of the great things that science does. It takes the knowledge that we do have and uses that to work out what we don't know. We know that organisms change and what the mechanisms for that change can be, and use that to help fill in the holes in our knowledge.
What led to the creation of the land-dwelling creature? This is a common thing within evolution, that you start at a fully formed creature and then evolve to another creature. But that's really not how things are supposed to have started. Everything's really supposed to have come out of the slime and out of the ooze, not start as fully formed creatures.
And nobody is claiming that Pachycetus just appeared fully formed. The article is not about the entire lineage from self-replicating molecules to whales, but the more specific land-to-sea mammal transition. If I want to trace my lineage from myself to my predecessors who came from England, I wouldn't need to talk about the ancestors all the way back to Africa that we all share, because that isn't part of the discussion. The article was simply discussing the relatively short, in evolutionary terms, change from a terrestrial to an aquatic organism.
Another question is, why did this land-dwelling creature change into a whale? Do we know? Or are we just taking a guess?
The best explanation is to exploit a new biome, either to escape creatures hunting it, or, and this is more likely because Pachycetus appears to be a predator itself, open up new hunting grounds. Fish live in water and are a good source of protein and other essential nutrients. Since it was a hunter, one branch of Pachycetus probably spent more time in the water hunting before returning to land for sleep, mating, and whatever else animals do. Crochet? This would allow them access to a hunting ground they didn't have to share with other creatures that exclusively hunted on the land. As they were spending more time in the water, ones that had mutations that would allow them to thrive in the water would be passed on, quickly moving through the population. As the populations became better adapted over time, they would spend more time in the water than out, eventually becoming conditioned to only living in the water.
Another good question to ask is, how did any transitional form of the species survive by procreation in this whole process? It seems that would become very difficult, especially in the transitional stages. Is anyone asking that question?
This question is only asked by people who don't really understand evolutionary theory, and there's nothing wrong with that. If you don't know something, asking questions, in good faith, is a good way to learn new things. In this case, when an organism that breeds sexually, that is, by mating with another member of its species, is born with a mutation that allows it to thrive, it's still going to be similar enough to the rest of the population that it can mate and breed viably with the rest of that population. It does not give birth to a completely new species that is biologically incompatible with the rest of the population. However, as those beneficial mutations add up, over generations the new genome will become more and more divergent from the original population. Eventually, it will have diverged enough that this new population would not be able to breed with the original, denoting that speciation has occurred.
Another good question to ask is, how do we take into account the complete reformation of the outside structure of a creature, and also factoring in that the complete inner workings of the creature have to be completely overhauled and changed? Evolution, especially if you go to like a natural history museum, a lot of times you're going to see bones. Bones going from this to this to this to this. The problem is that the bones are not really the problem. Do you know how complicated the digestive system is? The circulatory system? The nervous system? How are these things changing?
They aren't changing that much, really. If you're talking about mammalian species, the inner biological systems are remarkably similar. The digestive, circulatory, and nervous systems of sea-dwelling mammals are very similar to ours. Yes, there are some minor differences, but the blood gets pumped and food gets digested in very comparable ways.
If you start out with a land-dwelling creature, these things have to be completely restrung. You have to get the brain from one point to another point.
What? The brain moved from one point to another? What? I admit, I'm not a neurophysiological expert, but I'm pretty sure that from Pachycetus to whales, the brain was still housed in the head. Can we get an expert to confirm that?
Yes, all vertebrates' brains are in their heads.
Thanks, sweetie. What change from one point to another are you even talking about?
The nose has to go to the top of the head from the front. How does that happen?
How did this happen? Gradually. As organisms spend more time on the water than on land, a mutation that causes the nasal cavity to be located slightly higher up on the head will be advantageous to aquatic creatures and be passed on through the population. Over time, this will relocate the nose to the best suited position for aquatic-based mammals. This is known as nasal drift. No, drift with a T. As a population spends more and more time in the water, the resulting generations who are better equipped to breathe while staying mostly submerged in the water due to mutations will pass on those mutations to the next generation.
The skin has to become waterproof.
In the same way that nasal drift caused the nose of Pakicetus to move from the snout to the top of the cetacean head, a change in skin is explained through slow mutations. As these organisms spent more and more time in the water, the ones born with a thicker layer of skin that was better for living in the water would thrive and pass on that mutation because they could spend more time in their hunting grounds. Cetacean skin is now much thicker than most land animal skin and is constantly being sloshed off and replaced, similar to ours, but at a much faster rate.
The whale then has to have a diving apparatus too. How does that happen?
If we start with Pakicetus being a hunting animal, and its skeletal form seems to indicate that, and its descendants move to the water, it would slowly get physiologically better at hunting fish, the ability to dive and swim faster being instrumental. Small mutations would result in slightly better aquatic hunters. The better hunters would get better fed, meaning they'd be more likely to thrive and therefore more likely to breed, passing on those adaptations that made them better at living in the water.
All of these interchanges have to happen. There are many, many, many systems that are at work within an organism, and they all have to be changed and rerouted for really no reason. How is that possible? When you just see bones, it makes it seem so much simpler than it is when bones are seemingly just moving. And again, when we think about these changes that would have to take place, you would think that we would see more than 4 transitional creatures. We should more likely see thousands upon thousands upon thousands of transitional creatures.
The reason why we can't find every transitional fossil is that not every organism is fossilized. We're lucky to have the plethora of fossils we do have. There are many missing transitional forms between the fossils that we have found. However, we have good evidence that Pakicetus is the ancestor of whales. Whales have a unique inner ear region called the auditory bulla. Pakicetus, and also the other transitional fossils that we have found, have this structure as well. Fortunately for our attempts to trace whale ancestors, this inner ear region has not changed much, which helps us trace the evolutionary line.
Another question that no one asks is that when we have a change, an evolutionary change happen, doesn't that affect the entire ecosystem, the entire food chain? If one creature is evolving, the entire ecosystem, the entire food chain needs to be rapidly evolving to handle this. Everything has to be evolving if one thing is going to switch out of one capacity and take another. So how is the food chain able to be keeping intact and not collapsing on itself when one creature just decides to evolve?
Again, you have it backwards. The organisms in the ecosystem didn't evolve in order to accommodate a change, they evolved in response to a change. First off, nothing chooses to evolve. Creatures born with a beneficial mutation are at an advantage, and that mutation will be naturally selected and passed on through the population. Second, changes to one species can result in changes to another species in that biome, but the biome itself doesn't prepare for upcoming mutations. If a biome contained various species, and one had a mutation that gave it an advantage, other organisms would evolve in such a way in response to that. For example, by becoming faster or better able to camouflage themselves. Nature is in a constant state of flux. It's never preparing for anything, but random mutations will allow certain members of a species at the time to survive and pass on those mutations. And when one part of the biome changes, i.e. one species evolves, others will evolve to compensate. For example, let's look at garter snakes and rough-skinned newts. The snakes preyed on the newt, so the newts over time evolved the ability to secrete toxins through their skin. The snakes then in response, evolved a tolerance to that toxin. Over the generations, nature would select for more toxic newts and more toxic-resistant snakes. Tetrodotoxin is about 10,000 times more poisonous than cyanide. This co-evolutionary arms race resulted in extremely toxic newts, and also snakes that were surprisingly immune to said toxin. So immune to toxic foods, they could almost survive eating my cooking. Almost.
You know, if we go down to the bottom of this article, it says none of these animals is necessarily a direct ancestor of the whales we know today. They may be side branches of the family tree. Well, that doesn't sound like certainty to me. So we are certain that this did occur, but yet things may be something or other.
The issue is that scientists could be wrong, and they're willing to admit it. Yes, we cannot be 100% certain that each cetacean fossil we find is a step in the evolution between Pakicetus and modern cetaceans. The article could be right, even though they appear in line with what evolution has shown us. One fossil we found could be an offshoot whose lineage went extinct. We work with what we have to give us the best picture. While we might never be completely certain, science is about getting as certain as we can be with what we have. That's what's known as being intellectually honest. We can't even be 100% sure that evolution through natural selection is the cause of biodiversity. New information could come along to give us an even better explanation as to what caused the variety of life on this planet. But right now, all the evidence that we do have points to evolution as the most likely cause in the change in species.
I think the biggest kicker for this article happens at the end, and it says, as evolutionary biologist Neil Shubin points out, quotations, in one sense, evolution didn't invent anything new with whales. It was just tinkering with land mammals. It's using the old to make the new. No. No, 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 no. First of all, evolution does not invent anything, and it also doesn't tinker. Evolution has no mind. It does not have any capacity to invent or tinker with anything. And this is the rhetoric that is used in articles like this, and this is the problem.
To say that it tinkers is actually a pretty good analogy for evolution. Tinkering is making slight changes to a design to make it have new or more efficient ways to work. Evolution is very much like that. A random mutation will occur in a member of a population. This may be beneficial, harmful, or just benign. If this change is beneficial to the organism, it will be passed on to the population fairly quickly, because the organism with it will be more likely to thrive and breed. If it's detrimental, then the organism will be much less likely to pass on that mutation, since it will be more likely to die before it's able to breed. Nature tinkers with existing organisms through this cruel, arduous, but ultimately unguided by intelligence process known as natural selection. Over time, these changes will add up so much that organisms will be so different from their ancestors they will be unable to breed with them, which indicates that speciation has occurred.
We can also pose another scenario. Let's get some background here. The Big Bang is supposed to have come out of, nothingness. So the universe exploded out of nothingness. So that's the start. So in the scientific view, the start is that the universe came out of nothingness. So out of nothing came everything.
Not exactly true. We don't know what caused the universe. We have evidence that there was a massive expansion of heat and energy a little over 13 billion years ago, but we can't say what was before that. We have some hypotheses of what may have occurred, but we honestly don't know. It may be a continuing cycle, and this one happens to have intelligent life in it, a singularity that always existed. Who knows? But until we have a better understanding of the universe, and honestly, we may never, we can't say with any certainty as to what caused the expansion, only that it did occur.
So out of nothing, nothing, came things. And then out of nothing sprang up this process, this evolutionary process.
No, the biological evolutionary process began after the first self-replicating molecules formed. The evolution we're talking about only occurs when one self-replicating object is slightly different than its predecessor. If that change is advantageous, then it'll be passed on. If it's detrimental, it won't be. As populations split, this process will result in the diversity of life.
And so the consensus is this little passage that I'm going to read out of Nails in the Coffin of God. The consensus is that an unguided process using random mutation and natural selection has somehow created a supercomputer that is made up of cellular supercomputers that possesses a seemingly unlimited memory capacity and is in fact self-healing, self-replicating, self-sufficient, and to top it off, able to design its own self-updating software. Does this make any sense?
Yes, it makes perfect sense. Our ancestors were not the strongest or the fastest, and they didn't have natural weapons like claws. Their con levels were pretty good, but the thing that set them apart, that gave them the best advantage, was tool use. Making a cutting edge with a rock, or even using bones or branches as simple tools for getting nutritious bugs from unreachable places, would put one group at a much better advantage than another group who were just using their bare hands to survive. It would make sense that if our ancestors were dependent on their brains, the mutation that gave better brains would be extremely advantageous and would be passed on through the population incredibly quickly. Figuring out the best way to survive and preparing for their needs resulted in our ancestors building up their brains over many, many generations.
It's also self-replicating, babies. Imagine your disk drive popped out and a computer just sprung out of another computer. Wouldn't that be amazing? That's what humans do.
That's exactly what separates organic beings from designed objects. But let's take your example. Let's pretend we had a computer that makes almost perfect copies of itself, but not all the baby computers have the chance to self-replicate. If we only let the ones that had, say, the best memory or the fastest computing times be allowed to breed, eventually we would have a generation of computers that would have much better processors or higher memory than the original. That's exactly how evolution works, and what has resulted in our own advantageous mental perspicacity.
And another thing is that it designed its own self-updating software. DNA code is a software. It's a set of instructions that allows an organism to function. Software is a set of instructions that allows a computer to function. They're the same definition. So how does hardware, the body, program its own software, the DNA code? It's impossible.
Organisms don't program their DNA. Changes in DNA at the germ cell level will result in changes to the offspring. DNA doesn't update. If that change is beneficial, it'll be kept through natural selection. If it's detrimental, it'll be removed from the population via the same. Slight changes over time with the best adapted to the environment they find themselves in is the programming that you're referring to.
If we take any computer program, what do we find from that? Well, to create a computer program, usually the creator of the program exists outside of the reality of the program. So if you have a computer game and you have characters with code in them, usually the creator is on the outside programming the game. So if we have DNA code, it stands to reason that there is a creator.
But it doesn't stand to reason. We've shown that simpler RNA can form on its own. RNA-based life forms can mutate to be DNA-based, which, while more complex, is more stable, a beneficial mutation. This mutation will be so beneficial that it will be quickly passed on through the population.
A better analogy to evolution would be if we take a bunch of metal parts and then just put them in a room and let them float for a finite amount of time, because also evolution does not have an infinite amount of time, it has a finite amount of time. So if we have these parts floating around for a finite amount of time, that somehow a computer gets created and then that computer writes its own software.
I assume in your analogy that the parts floating around represent basic molecules. Jeremy England's work has been showing that self-replicating molecules will find a way to dissipate excess heat. Where's the self-replication in your mechanical parts analogy? Once we have self-replicating molecules, it's not surprising that changes, or mutations, will occur as the replications happen. As mutations occur and are passed on, organisms will become more and more complex. With the billions of years and uncountable generations of the guess and check method of natural selection driving it, it's not surprising that we have such a wide variety of biological life on this planet.
I stand a century